Welcome back, students. This is part 3 of 1.6, 1.7 transformations. I worked on the first 3 already, just to kind of talk about them and go through. So if you recall, what does x squared look like? Forget about the negative. X squared looks like this. It's a parabola. Negative. Where's the negative at? It's on the outside. Outside stuff affects the graph up and down. So we're going to reflect it up and down. So it normally would open up. Now we're going to reflect it down. So this is a reflection. Over the x-axis. Now that's a lot to write, correct? Let's abbreviate it. Let's go reflection over the x-axis. Just make sure your x looks like an x and not a y, because we're going to get to that. So here again, normally it looks like a V opening up, negative outside. We reflect it up and down, so this is a reflection over the x. And then this normally, square root, looks like half of our parabola this way. You reflect it down, you're reflecting that over the x-axis. Okay? Now we have a cube function. So I'm going to draw the parent graph this time, just so we can kind of take a look at it. So normally our graph looks like this, roundabout. So where's the negative at? It's on the outside. So this piece gets reflected down. That piece gets reflected down, then this piece gets reflected up. So our black graph is the final answer, and it's a reflection over the x-axis. Same concept here. We're going to draw our parent graph in red. So our parent graph looks... Oh, I said red. Now that's not red, is it? Reflection. Here's parent graph, a roundabout. It should look a little better in here. Should be a little bit better. Where's the negative at? It's on the outside, so we're going to reflect it over the x-axis. So this piece comes down here, and then that piece comes up here. All right. What's the parent graph here? It's a square root function. So it looks like that. Where's the negative at? Negative is on the inside. What's something inside do? Left and right. So we need to change the graph left and right. The negative on the inside reflects it to the left. What axis is that? That's a reflection over the y-axis. Right? Here's your y-axis. You're going to reflect it over that way. Okay? So you're going to like this one. It's x squared. Here's your parent graph. Reflected over the y-axis, because that's what this is. This is a reflection over the y, because it's the negative on the inside. You're reflecting it left and right. Guess what? Nothing happens. Reason being, if you simplify this, you get just x squared. Same thing with number 9. I'm going to skip number 8 and come back. Where's the negative at? It's on the inside. That means it's a reflection over the y. Well, normally it looks like a V. So reflect that left and right. Presto. It's done. You reflected it left and right, you got the V back. So again, knowing inside versus outside is crucial. Inside stuff is left and right. Outside stuff is up and down. So now we got to draw the parent graph here again. X cubed. So it looks like this. Where's the negative at? On the inside. So we're going to reflect it left and right. So this piece of the graph comes over here. So this comes over here, and then this comes over here. And what I want you to look, that and that look pretty darn close to the same, don't they? Yeah. They are the same. If you simplify this, you get negative x cubed. So they are the same. That is because it's an odd function. Odd functions, a reflection over the x and the y, are the same thing. They don't change anything. It's a reflection over the origin, technically. Anything that nothing happens when you reflect it over the y, that's called an even function. We talked about even and odd before. So that's where you see this. So again, here's the rule. That's the way it looks, all nice and formal, but it's in a nutshell what I just talked about. Okay? Why are we doing this? So we can graph things. At some point, we graph other things like log functions, and then we'll graph exponential equations, and we change them. We make changes to them. We'll graph sine and cosine. You don't know how that graph looks like, probably, but we change them up and down. We change them left and right, and the rules are all the same. So if you can graph x squared with the rules, and you can graph anything with the rules, as long as you know what the parent graph looks like. If you don't know what the sine of x looks like, then, okay, you're not going to be able to graph something that's been transformed. So let's take a look. What happened here? Oh, we have this +1, and then we have this 2. So two different things happen. So the first thing, we have a normal parent graph. I'm not going to draw the normal parent graph, but we have our normal parent graph. That's a parabola. What does the 2 do out front? You should do reflections first, then stretches or compressions, which no matter which way they go, and then you should shift. There are ways around that, but that is typically the way you want to work these problems. So we're going to vertically stretch this up and down. It's not a V, it is a parabola shape. So this is a vertical stretch by 2. And then it's a vertical translation up 1. So if I draw another graph, I'll just make it yellow for the sake of making it yellow. Hopefully it works. There we go. Ooh, that's too much. Let's try something else. Can I do another color here? Let's try this. So we're going to move it all up 1. That's not too bad. So you don't have to draw each graph. You can just draw it once. That's not a very good picture. I do apologize. But so you stretch the graph up and down. That means you're pulling it, making it taller and skinnier. The normal parent graph, if I drew that in black, I know I'm changing colors here. Normal parent graph probably looks like this black one here. So you're going to stretch it up vertically, and then you're going to move it up 1. So then we'll take a look at this. What happened? Well, we have a negative out front, and then we have this 3. So two different things happen. What does a negative out front do? A negative out front is a reflection over the x. All right? What does a 3 on the inside do being multiplied? Well, something on the inside, left and right, so it's horizontal something. So are you making the graph taller and skinnier? Are you pulling on it? You're pushing it? What are we doing? Well, we are going to take the graph and we're going to compress on it sideways by, be careful about this, by 1/3. Remember, something on the inside, you always have to go opposite or do something opposite. So knowing that it's a negative, first I'm going to reflect it over the x-axis. So it got reflected down. And then, that's my first graph. Parent graph is the V. And then I'm going to compress it horizontally. So the red is the final graph. All right. Let's come over here. Number 3, identify what is being changed. There's a negative, and then there's a 1/3. Notice they're both on the outside, so that means something vertically is going to happen. So this is a reflection over the x-axis. So my parent graph looks like this. My new graph looks like that. Maybe a little too stretched. Let me try that again. It's too stretched. There we go. And then what does 1/3 do? Well, it's going to do something up and down. It's being multiplied. It's a vertical stretch or compression. It's going to be a vertical compression by 1/3. So we're going to smush the graph up and down. It's going to grow slower. Think about your money. If I take 1/3 times your money, you're not going to have as much money. Okay? Number 4 down here, we have 4 things happening. We got a -4, we got a 2, and then we have a negative. They do not do the same thing. They do different things. So our square root function goes like this, but there's a negative on the inside. What does that do? That is a reflection. Come on, pen. Sorry about that. It's a reflection over the y. So we're going to reflect this way. Then what does the 2 do? It does something on the inside. It's a horizontal something. A bigger number than 1 on the inside is going to be a horizontal compression by 1/2. So we're going to take this graph and we're going to compress it. And then we're going to shift it all down 4. So that's a vertical translation down 4. So take this stretch graph, go down 1, 2, 3, 4. Tried to make it red, but that didn't work. So the red one is the final answer. Do you have to draw more than one graph? Absolutely not. But if, when in doubt, do one thing at a time, drawing multiple graphs. Okay? And then number 5, we got a +1 here and a 1/2 here. So there's 2 things happening here in this graph. What does the 1/2 do? That's a vertical compression by 1/2. And then the 1 is a vertical translation up 1. So we're going to take our graph and we're going to compress it vertically. So it gets wider. Normal parabola kind of looks like this. And then we got to stretch it up 1. So we stretch it up 1. Or no, sorry, we don't stretch it up 1, we move it up 1. So, oops. All right. We've got 3 things happening here. We have this negative, we have this -4, and this +1. What does the negative on the outside do? It reflects it over the x-axis. So I got a parabola that's now going to open downward. What does a -4 do on the inside? Subtracting 4 is going to shift it right. 1, 2, 3, 4. Doesn't change its shape. And then you got to move it up 1. So my final answer is this one. So if you need to, you can erase some of the other ones if you need. Oh, that didn't work. Okay, I'll leave that alone. Don't want to mess with it too much. All right. Okay, so for these, this is just like working backwards. You have to identify the parent function, and then you need to say what happened to it. So for number 1, it's an absolute value function. So it's y. Yep. Not letting me draw right now. There we go. It's y equals the absolute value of x. But now we're going to have some changes to it. So it's translated, which means to move, 4 units down and 2 to the right. 4 units down and 2 to the right. So let me erase that. How do you move something 4 units down and 2 to the right? Well, down 4 is -4 on the outside. To the right, you go opposite on the inside, so that's -2. That's not a 21, that's an absolute value bar. A quadratic function reflected over the x-axis and translated 3 units down. So how do you reflect over the x-axis? It's -x², -3 on the outside. A square root function reflected over the y-axis and compressed vertically by a factor of 1/2. So 1/2 goes on the outside, -y on the inside, -x, not -y, -x on the inside. Okay, and running out of time, but I want to make sure I get these in. A quadratic function stretched vertically by a factor of 3. 2 units up and 1 to the left.